Hello, my bright physicists. Let's start with a mind-bending thought. Have you ever looked at the sun through a magnifying glass and noticed how its huge size shrinks to a tiny burning dot on paper? That's exactly what happens with concave mirrors too. When the object is at infinity, say the sun, the incoming rays are practically parallel. And a concave mirror, being the perfect ray disciplinarian, says, all of you meet at my focus F. The result? A sharp, tiny point image formed at the focus. And here's the fun twist. This image is real, inverted, and reduced to almost nothingness. Just imagine the gigantic sun compressed into a single blazing dot. Now let's bring our object a little closer. Suppose you're looking at a faraway tree through a concave shaving mirror. The rays coming from it are not exactly parallel but nearly so. One ray strikes at the pole P, reflects back with equal angle, while another sneaks through the center of curvature and retraces its steps. Both rays intersect not at focus but at the focal plane, a little screen just beyond the mirror's focus. The image here is still real and inverted, but now it's highly diminished. Think of it as compressing a tall tree into a tiny matchstick version on your mirror. Alright, what if we move our object beyond the center of curvature C? Let's say a friend stands way back in front of your concave mirror. Here's what happens. A ray parallel to the axis passes through focus F, while another ray through C retraces its path. They meet between C and F, giving a real, inverted, and smaller image. So your tall friend suddenly looks like a mini version between C and F. It's like the mirror is politely saying, I'll keep you real, but I'll shrink you down a little. Now place your object exactly at the center of curvature, point C. This is the mirror's way of showing fairness. Rays exchange roles, one through F becomes parallel, and one parallel passes through F. They meet right at C itself. So, the image is real, inverted, and of the exact same size as the object. No bias, no magnification, no shrinking, just a truthful reflection, only upside down. It's like the mirror saying, I'll mirror you perfectly, but don't complain about the inversion. Now the fun begins. Bring the object closer, between C and F. A parallel ray goes through F, a ray through F emerges parallel, and when extended, they meet beyond C. The result? A real, inverted, and magnified image. Yes, the mirror has become your personal projector, enlarging everything. That's why dentists use concave mirrors. They want your tiny tooth to appear like a giant billboard while they work on it. Here comes the dramatic twist. Place the object right at the focus. A ray parallel to the axis passes through F, and one through F emerges parallel. But here's the kicker, they never meet. Instead, they run off to infinity. The image is formed at infinity, real, inverted, and infinitely magnified. It's as if the mirror says, sorry, you're too close. I'll just throw your image out into space. Now comes the only case where the concave mirror breaks its pattern. Place your object between the focus F and the pole P. What happens? The rays, when extended backward, appear to meet behind the mirror. So this time, the image is virtual, upright, and magnified. This is why makeup mirrors are concave. They make your face appear larger and upright, helping you perfect that eyeliner wing without squinting. Alright, time to bring in the maths to check our story. The mirror formula is 1 by F equals 1 by V plus 1 by U. Suppose our object is 30 centimeters away from the mirror, so U equals minus 30 and the focal length F is minus 10. Substituting, 1 by V equals minus 1 by 10 plus 1 by 30. That's minus 3 by 30 plus 1 by 30 equals minus 2 by 30. So V equals minus 15 centimeters. That means the image is real, inverted, and lies between C and F, exactly what our ray diagram predicted. Isn't it neat how geometry and algebra shake hands here? So to wrap this up, let's quickly recap the mirror's drama performances: at infinity, image at focus, real and tiny. Beyond C, smaller, real, inverted. At C, same size, inverted. Between C and F, magnified, real, inverted. At F, flung to infinity, highly magnified. Between F and P, the only upright and virtual case. That's the magic of concave mirrors, from showing the entire sun as a dot to making your tooth look like a monster. I hope this gave you not just the rules, but also the intuition behind them. Next time you look into a concave mirror, remember, it's not just reflecting you, it's telling a physics story. See you in the next session with another exciting adventure in light.